So this video, I just kind of wanted to go back and talk about some fundamentals in algebra and just go back to some basic stuff that is really going to help you if you want to continue down the road in advanced mathematics. So this time we're going to talk about real numbers, which is denoted by the blackboard bold R. So real numbers just goes from negative infinity to positive infinity on the number line. And it can be broken up into several different groups and subsets, several different subsets. So the first subset we're going to talk about is the natural numbers. So all of these subsets that we're talking about, they're all real numbers, and they're just subsets of the real numbers. So the first one is natural numbers. This is denoted with the blackboard bold N. So if you see this in a textbook, it's going to be just regular boldface. But since we can't really do boldface with a pen and paper, we're gonna use this notation here. So the natural numbers or counting numbers are numbers that we see in real life and we can count. So it's going to be 1, 2, 3, and go on to infinity. So the natural numbers are going to start at 1. Let's use a different color. Going to start at 1 and go on to infinity. So these are natural numbers. All right. The second subset we're going to talk about is integers, which is denoted by blackboard bold Z. And integers go from negative infinity to positive infinity. Just like real numbers, they are real numbers, but they're integers, so they're whole numbers. So these are integers. So as you can see, the natural numbers are a subset of the integers. The next subset we're going to want to talk about is the rational numbers. Which is denoted by blackboard bold Q. So rational numbers are fractions. They can be looked at as a rational number is a ratio of two integers. So R equals M over N with M and N element of Z. So, 1/3, 1/2, 2/5. These are all rational numbers, meaning it's a ratio. 1 is an integer, 3 is an integer, 2 is an integer, 5 is an integer. So these are ratios of integers, 1/3, 1/2, 2/5. So these are rational numbers. They can be expressed as ratios of integers. The fourth one we're going to want to talk about is irrational numbers. This is denoted as a bold I. So these numbers can't be expressed as a ratio of integers. So this can be expressed as a decimal, 0.333 repeating, or 0.5. But irrational numbers are decimals that cannot be expressed as a fraction. So we're looking at square root of 2, cube root of 2, pi, because square root of 2 is, 1.414 and goes on. Pi is 3.1415 and goes on. So writing square root of 2 is the simplest form we can write it in. This is an exact number, and it's irrational because it cannot be simplified into a ratio. of integers. It's a continued decimal. Okay, so now that we kind of have a feeling of what all makes up the real numbers, we can go on and look at some properties of these real numbers. These properties are going to be really important if you go into group theory. We're going to go over what it is to be commutative and associative, and if you're going to go on and prove that something is a group in abstract algebra, you're going to need to know what it is to be commutative and associative. If you're going to want to prove it's an abelian group, when you look at rings, it's going to be really important. So the fundamentals here is really important to get under your belt and securely under your belt. So first, let's talk about what it is to be commutative. Being commutative, let's first talk about under addition. Means that if we have, in this case, real numbers, two real numbers, let's say A and B. So if we add A and B together, we know that it will not change the answer if we write it as B plus A. So you can change the order and it will not change the answer. So for example, if we say 3 plus 7 equals 7 plus 3, we know this is a true statement. 3 plus 7 is 10. 7 plus 3 is 10. So this is true. So the group of real numbers is commutative with respect to addition. We can change it and it doesn't change the answer. Now let's look at under multiplication. Same concept here. If we take A and multiply it by B, we're going to get the same exact thing as if we take B and multiply it by A. So 7 times 3, and we're going to use a dot here. And, you might be used to using an X, but start getting used to using a dot because it's what's going to be the standard for multiplication. So 7 times 3 equals 3 times 7. These are both 21. We know that. In contrast, you know that the group of real numbers is not commutative under subtraction. 7 minus 3 is 4. 3 minus 7 is negative 4. Those are not the same number. So the answer does change if you switch it. So it's important to know that operations are not all commutative under real numbers. The second thing we're going to talk about under properties is associativity. So first, let's look at under addition. What does it mean to be associative under addition? Well, if we have three real numbers and we're adding them together, what it means if it's associative is that it doesn't matter what order we add them. So we can add A plus B first and then add in a number C. Or we can add A to the sum of B plus C. It doesn't make a difference what order we add them. So here let's look at 2 plus 3 is 5, plus 4 is 9. Here if we do 2 plus 3 plus 4, 3 plus 4 is 7, plus 2 is 9. So we got the same thing here. So real numbers are associative under addition. We can similarly look at the operation multiplication and say we can multiply A and B first and then multiply C, or we can multiply A times B times C and we'll get the same result. So 2 times 3 is 6 times 4 is 24. Or we can say 2 times 3 times 4. 3 times 4 is 12, times 2 is 24. So we get the exact same result. All right, so the third property I want to talk about is the distributive property. So what does it mean? Well, when we multiply a number by a sum of two numbers, we get the same result as multiplying the number by each of the terms, then adding the result. So the best way is just to see an example. So if we look at it in general, we have a times x plus y. So if we use the distributive property under real numbers, we know that this is equal to a times x plus a times y. Okay, we can do the same thing if we want to say x plus y times a and multiply x times a and add y times a. These are the same thing because remember earlier we said that real numbers are associative. So it doesn't matter, and commutative. So it doesn't matter which order we add these two things, and we can flip the x and the a and the y and the a because it's commutative. So ax plus ay. So these are the same thing. So let's look at an example. First thing I want to look at is an example of the distributive property. So just like here, we can multiply this 2 out. So first we're going to multiply it by the x, and then we're going to multiply it by the 3. So we get 2 times x, and our operation here is addition, plus 2 times 3. And then we can just multiply this out. So this becomes 2x plus 6. Okay? So let's look at a little more complex of a problem. So now we're going to use the distributive property, but we're going to have two quantities multiplied together. So we're going to take, just like before with this 2, but now we have a quantity here, a plus b, and we're going to multiply that by the x and that by the y, just like we did with the 2. So here we have a plus b times x, that was the first step, plus, that's the operation here, a plus b times y. Now we use the distributive property there, but now we're going to use the distributive property again to continue to simplify this expression. So now, just like we did before, we're going to take this x and multiply it by the b and the a. And we're going to take this y and multiply it by the b and the a. So this becomes a times x, or x times a. Remember, it's commutative, so it doesn't matter. And we're going to add, the operation is addition, b times x, or x times b. It's commutative, so it doesn't matter. We're going to add this to a times y times b times y, plus b times y. All right, and then finally, let's just write it as ax plus by plus ay plus by. Since it's associative, we know it doesn't matter what order we add any of these things, it will get the same result. Okay, so there are some properties and some examples using real numbers. And next time we'll talk about real numbers again and talk about properties of negatives and properties of fractions.